Right, so in this session we'll see programming for Simpson 1/3 and 3/8 rule. Simpson 1/3 rule. So it is y is equal to h by 3 y0 plus yn 4 times y1 plus y3 plus y5 plus 2 times y2 plus y4 plus y6 plus etc. So that is Simpson 1/3 rule. And Simpson's 3/8 rule, y0 plus yn plus 2 into y3 plus y6 plus y9, all multiples of 3 plus 3 times all other terms. Right, so you have to write a program for this. Alright, so integer I. So what are the inputs? We have to give the lower limit, upper limit and step size. Otherwise number of intervals. Number of intervals is more convenient. Let's say what is the function? Let's say 0 to 3. This is the function. So we need upper limit, lower limit and number of divisions. And step size is h. So what are the things that user has to supply? Otherwise give specifically lower limit, upper limit and number of intervals. to calculate h. H is b minus a by n. So here these two numbers are real numbers, so we don't need to worry about it. The result is a real number. Okay. So now I have to calculate this. y0 plus yn, 4 times odd numbers and 2 times even numbers. So initial value is fixed. Let's say y is equal to we have to define a function also, right? F of a plus f of b. Initial values. That multiplication factor we will include at the end because it is a simple repetition of activity. So that will multiply at the end. So we are initializing y with f of a plus f of b, starting value and ending value. Then we have to add 4 times odd numbers and 2 times even numbers. We can do that in single step or 2 times separately. Let's say I am starting with I1 to n minus 1 with a step size of 2. Each time I will consider 2 terms. Instead of doing it twice, I consider 2 terms at a time. So now what I have to do, y is equal to y plus 4 times f of a plus IH plus 2 times f of a plus I plus 1h. Four times f of a plus IH and 2 times f of a I plus 1h. So in the first stage it takes a plus 1h and a plus 2h. Next stage I increases by 2, so I becomes 3. So 3h plus 4h. So like that it continues, and at the end the result is h by 3 times y. So it is convenient to take the number of intervals to be multiples of 3, because here we are considering each 3 terms separately. It is more convenient to consider the number of terms to be multiple of 3, either 6, 9, 12 kind of. Okay, so what is the result? So this is a second order function, quadratic function. So Simpson 1/3 rule will give you exact result. So what is the result here? X square x cube by 3 plus x square plus x 0 to 3 raised to x square by 2. So it is x cube by 3, 27 by 3 plus 9 plus 3 minus 0. So 9 plus 3 21. You should get 21 as a result. Here this y1 comes here, and we have to write 2 times odd terms. Sorry, 3 by 2.
1 by 3.
4 times or 2 times, huh? Okay. 4 times or 2 times, antena? Sorry. So if we go up to n minus 1, what happens? We'll be adding the nth term also here. N minus 1 and n minus 1 plus 1. So we have to consider only up to n minus 2. I is 1 to n minus 2 with a step size of 2. And the last term would be n minus 2 and n minus 1. 4 times n minus 2 and 2 times n minus 1. Y n minus 1. So that will solve. Right, so to apply, to write the program for 3/8 rule, the same way you have to consider up to 3 terms here. So let's say here y is equal to f of a plus f of b is the same. Do I is equal to 1 to n minus 3 with a step size of 3. Y is equal to y plus three times f of a plus I star h plus f of a plus I plus 1 star h plus 2 times f of a plus I plus 2 star h. And do, and the result is 3h by 8. So here, depending on the number of intervals, one term is missing always, sometimes. So we have to calculate these things separately, then only it works. So we have to take all odd terms separately and even terms separately and add. So do I is equal to 1 to n minus 1, the step size of 2. I'm considering all odd terms. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Exclude these two and consider all odd terms. This one, y1, y3, y5. So I have to consider y1, y3, y5 up to n minus 1. I'm considering n is equal to 6, a is equal to 0, b is equal to 3. So I want to n minus 1 up to 2, y is equal to y plus f of a plus I star h. Ended. These are odd terms. Then I have to consider even terms. Here also, you have to consider them separately, then you will get the result. So y is equal to f of a plus f of b, initial step. Then do I is equal to 1 to n minus 1 with the step size of 2. That gives you all odd terms. That will not work, right? We have to exclude the terms with multiples of 3. So here you strictly have to give n must be a multiple of 3. So in that case, first term is okay, last term is okay, done. Then the first stage you have to consider these 3. Next stage you will be left with only 2. One. So that is why it is giving an error. equal to 1 to n minus 3. If I keep 6, 1 to 5. What does it give? F of 1 y1, y2, y3. Plus next series y4. Here we will get excess term. y5 and y6. So that third term should be handled separately. So up to this part this is okay. This we will see in the next session. When here we are considering all odd terms separately and all even terms separately and adding them. So here we have to deal with the terms with multiples of 3 separately. I mean, they should not be repeated in odd terms. So we need a separate logic for that. We'll see in the next session. Here one term is all odd terms 4 times. So that is all.